All right, the recording started. Let me start. So the agenda for today's class. That means many people have showed up. Lisa promised she will gonna show up on that will get it. But anyway, Joe promised she will show up as well, right? Joe said that. Almost everybody is here. Anyway, so the goal for today's class is to do two math problems. Okay. I'm gonna do one, and the other one is exactly similar to the first one. Okay. Hopefully you can deal with the second one by yourself. Now, everybody remember the normal and tangential component of the acceleration? We're gonna use that today. As you can see from the problem itself, that a circular path for a ball, and this ball had a velocity of 3 meter per second, uh, rounding to clockwise direction, and with the horizontal line there is an angle of 45 degree, and the radius of this circle is 2 meters. So those are givens. Okay, just 1 second, let me get my class note as well. All right, so those are given. So it says here 10 kg ball has a velocity of 3 meter per second. When it is at position A, this is position A, along the vertical path. Okay, and then you got to find the tension in the cord and the increase in the speed of the ball. Okay, so basically they are asking the tension. So if you can find the tension and the increase of the speed, what does it mean? Increase of the speed? Acceleration. Okay, that's what you got to do. All right, let's start with the free body diagram. And as I said, if you have a class ready. So as I said, I'm gonna do the first problem. Okay, this one in detailed manner. We'll try to explain each and everything. You may ask me a question. The second problem will be exactly similar to the first one. Okay. All right. So you can do it by yourself. So first of all, for this block itself, there is the weight acting downward, right? So this weight is acting downward. So if I'm gonna draw a ball like here, the weight is acting downward on the top of the ball. Okay, and there is a tension force, right? And then tension force with the horizontal line. What is an angle of the tension force? Anyone? 45. Okay, we just have these two forces, right? And then you have these two different direction. Okay, let me see if I can do those direction in a little bit different color. Blue color. That 45 doesn't look like 45, is it? Maybe. How about now? Does it look like 45 now, Brad? Yeah. Kind of. All right. So now we can say, okay, I have these two different axes. One is tangential, another one is the normal. Which one is tangential? The bottom one or the top one? Obviously the bottom one, right? Doesn't look exactly bottom, but it has an angle towards bottom. So that's the tangential direction, right? And this is your normal direction. And normal direction always goes towards the center of that circle or path. Here, this case is a circle. All right. So this W here is not acting either in N or T direction. So it does have these two components. Everybody understand that, right? It has this N direction component and Y direction, sorry, not Y, T direction component. And the W can be reduced to W cos 45 and W sine 45. Do you guys agree? Now, when it comes to 45, it really doesn't matter whether you do cos 45 or sine 45 because the value is the same. Just remember that cos 45 and sine 45 value is same. You know that, right? Cos 45, sine 45 value is same. Cos 45 degree, sine 45 degree. Okay. All right. So if that's the case, I can write this W. I'm gonna use another color. How about blue? Say like this W is coming down like here, right? This is the same W. And now we can deduce it to two different components, right? So one component is in t direction, the other component is negative n direction, right? And what is this angle again? This angle is 45. We know that, right? So this angle should be 45 as well. So can I write? Now I'm gonna make it solid. Now we're ready. So can I write this one as W what? Cos or sine? Okay, sine. This is my W. So this one will be W sine 45. You know which one I'm referring. This is my W, right? This one is my W sine 45. And cos 45 is a little bit difficult to write. Let me try to still write it. W cos 45. Everyone understand this, right? All right, perfect. So if you understand this, then you can literally finish this problem by yourself now. So you know, ultimately, the resultant motion on this ball is in one is in t direction and one is in n direction. So this would be considered as MAN and MAT. Now this is a t direction and this is your n direction. Now see, anybody ever played with a ball like rotating like that? So when the ball rotates along a circular path, ball doesn't care what is the tension, what is the weight and everything, right? It is not ball's headache. Ball's headache is only to see what is the acceleration. Okay, does it make sense? So that is your resultant. That is your resultant. And this is what you are using for doing the analysis. You understand? This is what is resultant. Now, why I'm saying that? Now, between the summation of Ft and summation of Fn. And when you do summation of Ft, in the left side, you'll be getting all the forces in t direction, right? And the right side, in the equation I'm saying, you'll be writing MAT. Does it make sense? So that's the first equation. In the second equation, you'll be writing summation of Fn. Okay. On that one, on the left side, you'll be getting all the n direction force, and the right side, you'll be writing MAN. Does everyone understand this? Logan, you got it? Yeah. Okay, perfect. Now I'm gonna write these two equations. What's my purpose again? My purpose to find the tension. The one thing that we can actually find before even we go for tension, which is the acceleration AN. Can you find the AN value? You guys remember from exam 1, what is the equation for AN? Is it like V squared divided by rho, right? Rho is what? The radius of curvature, or radius in this case. You know the radius, you know the velocity, you know find the AN. So you are gonna need that AN when you're gonna do those two equations that I was saying, right? So let's do that. The givens and find everything is in engineering format already. And this is what I do draw is called free body diagram. And this is they call kinetic diagram. Okay. These are the term, is a keyword, okay? Remember those terms. And then obviously you're gonna find two things. First, this weight. Is the weight directly given, Brett? Yeah. You have to do this mg, right? The m is 10 kg. What is the g value, Gavin? 9.81 in this case, right? So the force value, once you're going to do the math, 19.81. What would be the unit on this, Renzo? Is it a pound or Newton? It's Newton, right? It's Newton. It's in SI unit. All right. So that's your weight. And now you're trying to find acceleration. Okay. AN is V square divided by rho. What is the value of the V, Christian? The velocity? 3. Is given, right? 3 meters per second. And log 1 was the value of the radius. 2 meter. So we're going to do the math. You're going to come up with this value 4.5 meter per second square. Now we are actually ready officially to deal with this math. Okay. Now when I'm saying officially ready, you gotta use the equation of motion. You remember Newton's second law. That's the equation of motion, right? F equal to ma, or in this case, summation of F equal to ma. So that's what we'll be doing. So apply the equation of motion. In two different directions. One is in Fn direction, which would be man, right? The other one would be in, I'm keeping some space for writing the equation, in Ft direction, which would be mat. And the Fn direction, let's try to focus that, in n direction, from the free body diagram, what are the forces in n direction? N means the normal direction. First one is T for sure, right? The tension. Right, Kenzo? When you are rotating this, right, you have the rope. Rope will gonna pull, right? So that's the tension in n or normal direction towards the center. Does it make sense? So that's the T. What happened with the W? It has two components, right? Only one component will gonna be in n direction. So you have these two forces. That's it. Is there any more left, or just these two? Just these two, right? All right. Let me write them then. So you have in the left side T. Now, depending on the direction that you are using, your direction is towards the center positive, right? So T should be positive. That's the tension direction. So T minus W cos 45. Okay. Because I was explaining this n direction force, right? Summation of Fn. Here there are two forces. One is the T, the tension towards the center, and is positive, okay, and the other one is W cos 45, the one component of W, that would be opposite to T, that's why it's negative, okay. And then you would always, so that's another trick, on the right side you would always write the AT or MAN towards the positive direction, okay, towards the direction that you use for X and Y, in this case A and T. Does it make sense? So you always do that. And then you're going to solve this to find the value of the tension T, right? And you see, the question has two parts. Question asks you to find the tension and the acceleration. Now you may argue, I already found the acceleration. It's partially true. You found one component of the acceleration, right? The other component of the acceleration, like AT, you didn't find it, right, Christian? So you need two equations for these two unknown. You understand? Once you have that AT, you already know the AN. You find the value of the A, resultant A, like Pythagorean square root of AT square plus AN square. Everybody did this before, right? So that's the technique. All right, so let me solve this. So obviously this T is unknown, so I'm gonna write everything like moving this W cos 45 to right side, and then start to plug all the values. So I do have this MAN here. M is 10, AN is 4.5, and this would be Newton, right? Plus 98.1 cos 45. This would be Newton as well. And I'd like to take it out. Don't want to be congested at all. So this T will gonna be, anybody would like to do the math, or you're gonna do it for the second problem? You have to use the calculator anyway. You have to do the math for this one or the second one, okay? We do have plenty of time to deal with two math problem, and these are easier math, okay? So I mean, I'm encouraging you to do the math, but if you are doing it, you are actually shooting for this 114 or 104, 114, 114 Newton. Okay, that's the tension T. You'd like to possibly put a box here, and then you are doing again equation of motion in T direction. Then you have Ft MAN, and I'd like to stop here so you can finish the thing what I said so far, and then Let's see if you can write the second equation. How many force in t direction? Let's see if you can figure it out. Once you're done, let me know. So I can kind of guess that you guys are engaged. Everybody got 114? Okay. How many force in t direction? From the free body diagram. Just one, exactly. Which is W sine 45. Now that's your left side. Even though I have submission side, I don't have any other force. I couldn't find any. I don't need any. That could be enough. W sine 45 equal MAT. Now this W is known. 45 is 45, right? Or 45 sine 45. And M is known. Can you find the AT? I'm saying like this is very easy problem. One of the easiest one. Okay, that's your job now to find the value of the AT. Okay, let's see if you can find it. So you have this W sine 45, then M AT. I'm gonna write the same thing again, and then now this is the time I'm gonna start plugging the values. So sine 45, this is in Newton, 10 kg, and this A mass needs to be in meter per second squared. If you're gonna do the math, you're gonna have 98.1 sine 45. You're gonna put a cross sign or multiplication sign. 10 kg. This is in kg per second square. Or Newton can be written that way, and the value will be 6.94. Okay, meter per second square. That's your AT. Now, when you're done with that, there's a final step. The A, or acceleration, can be found by doing this Pythagorean, right? I'm just doing it a little faster because I know this is exam 1 topics. Everybody done it. So I have 4.5 square, 6.94 square meter per second square, obviously. The value would be 8.26 meter per second square. This meter looks a little weird. Hopefully it does make sense now. So that's my A and the final answer. Okay. Okay, I'm giving like 1 or 2 more minutes so everybody to take the class note, finish the class note, let me know when you're done. So I can show you the second problem, and I'm expecting you're gonna finish it by yourself. Okay. Very, very similar one that I have. 2 more minutes, let me know when you're done. So give a quick wrap up. What happened here? We're trying to find the tension and the A. Now, AT is something we've got to find. AM can be found by using B square over rho. Okay, and the W is FG can be found as well. And then we do these two equations, summation of FT and summation of Fn. Okay, and from there we have two equations to unknown. We were able to find A and AT and T. Okay, and AT we're gonna eventually give as A. Any question? Everybody got it? All right. Let me know, Brett, when you're done. Good. Good. Moving on. So this is the math. See if you can solve it. It's just one thing that I'd like to say. Person hit a swing. Okay, in a swing. Now, how many ropes usually in a swing? It could be 4, it could be 2, but we're going to use 2 here, right? It may come like this way. I can assume it's 2, right? So 2 ropes. So the tension is here 2T. Okay? So that's the only thing to remember when you're going to do the math. Okay? Isn't it the similar problem? A person or a baby is sitting on the swing, and the baby's weight is going to act downward just like the ball, right? Make sense? It's exactly the ball problem. Except the ball, you just consider there is a baby, and except one rope, we have 2 ropes. So it's Now I'm gonna give you 10 minutes. I'm gonna walk around, and once the 10 minutes pass, then I'm gonna start writing the solution. Okay, then you can match. And by these 10 minutes, if you can finish it, get the values, and I'm writing those answers here. If you get these answers, then you can leave. So these two things that you want to find. So the value would be two supporting chords. It just says two supporting chord, right? So the value would be one chord. That means it's 2T here, right? So the tension value would be, oh, there's another thing to notice here. This is a English unit problem, okay? So very careful. 32.2, yes, 32.2, but you may avoid the 32.2 as well. What is this? Weight is 60 pounds. So this is the W. Okay, you don't need to multiply it with 32. You remember, that's the pound force. Okay, if you're gonna use it that way. Anyway, so this tension T is 46.9 pound. Okay, and the acceleration and the acceleration A would be, do I have the acceleration calculated? I don't, for whatever reason, I don't know, but I have this AT calculated. So AT value is 16.1 feet per second square. N is, I do have the N, I should, 22.5 feet per second square. That's the final answer. If you got those answers, that means you're done.
What is the distance? Or you know, is it 10 feet?
10 feet, it's 10 feet. As the radius of curvature is 10 feet here, rho is 10 feet. That would be a perfect practice. Oh, by the way, I'm gonna upload a homework. And it won't be due until you come back on Wednesday, okay? So break, you don't have to do anything. You're done with whatever I gave you. And there's exam. When you're gonna come back,
the W, what would be the mass then? Is it still 60?
The angle.
For like,
If that's the W, I didn't hear the last thing. Is it like if that's the W, the last thing I didn't hear?
what's the mass? Is it also just?
Oh, the mass is like 60. And if you want to get it like 60, so in English unit, it goes this way, like pound mass, pound force. Okay, so you can say 60 pound as well, but it could be pound mass. But there is another way of expressing it's called slug. Remember that?
Yeah.
If you want to deal with the slug, don't deal with the slug in this problem. Okay, just deal with this pound force. Okay, then life will be much easier. You don't have to worry about G at all. Okay, there's no point of just use this 60 pound. That's what the result come up like the T is 46.9 pound. Okay, if you have that W as in pound, this W would be this T would be as in pound as well. Okay. Yeah.
Could you just head over to my, come over here.
You're in slide?
No, I'm kind of where Logan's at when he asked. So there's gonna be an M in the equation, no?
Yeah.
So how would we find the M again? Like we would.
Yeah.
Well, at first I was gonna do the 60 divided by the
30
Yeah.
Yeah. So you have this M needs to be divided by 32.2 for sure, because that's the M in pound mass. But when you're trying to equate them, let me write this equation. Okay, I know this is confusing. So Fn MAN, right? You are in this form, right?
Yeah.
Okay, so now you have 2t minus W sine 60 equal MAN. Now this 2t can be written as MAN plus W sine 60. Now this MAN T can be written as MAN plus W sine 60. Yep, Logan, sorry, I did confuse you. So this you have this 60 multiplied. You have, what is the AN value you guys found? 22.5, right? Which is V square divided by rho. That's a meter per second square. So this is 22.5, and the whole thing you would like to multiply it by 32.2. Sorry, I know I probably confused you guys. Okay, so this would be in pound force. All right, and then you have this 60 sine 60, and you have this pound force here, right? This makes sense now? All right, so then you're going to be finding this. I'll be only doing this T, okay? And I'm hoping you can deal with the other one, right? And I'm just doing this free body diagram, okay? So this guy, this baby here, assume the baby is a point, okay? And then you have this 2t acting in this direction, okay? And then if you're gonna put this force, it is 2t in this direction, and the baby does have some weight acting downward, right? So that's the baby weight W here, and then there's this N direction. That's the T direction, because the baby is moving along this direction. So that is my N direction. So let me try to stick with this, and this is my T direction. Okay, if that's my T direction, understanding this angle is so important. So you have this angle. What is this angle? I'm claiming this angle is 60. Okay, so the reason this angle is 60, you see, this angle is 60. Does it make sense from geometry? All right, so this is how I got this angle 60. If you know this angle is 60, then I can write this. W has these two components, right? So one of this component in this direction, and the other component is in this direction, right? So one is the one, this direction is W cos 60. When this direction is W, sine 60. Okay, this W needs to be here. Here. Hopefully it does make sense, right? All right, now can you do the other one? Like, what is the other one? Oh, which is equal to the kinetic diagram. So assume still the baby is the ball, and you have this resultant is going on one in n direction, which would be m a n, and another one is in t direction, m a t, right? So then you can write the other one should be ft, which would be equal to m a t, and then this would be become along the t direction, right? It would be w cos 60 and then m a t. And what's the goal here? To find the at, right? So at should be equal w cos 60 divided by m. Now you already know what to do with the m, right? You're going to divide the m by 32.2. That's how you're going to find the value of the at. Let me know when you have some value of at. And actually I have the value of at written over there.
So that means W is acting at an angle.
Now w is acting
So
vertically down.
why are we splitting it? Sine,
You
cosine?
do have this at and an has angle. So you want to distribute this w towards the at, and I'm not sure it's at, towards the t and n direction. So t is the tangent direction and the normal direction, because the traction is in normal direction, right? So that is the reason you are going to write it. So obviously you might have something like that already. 60 cos 60 divided by, you had this 60 again. There's the mass, right? This time 32.2. It's a little difficult to understand, right? The whole thing unit is feet per second square. Okay, and then you will have this 32.2, 1660 will cancel out, cos 60 feet per second square. 60 just look like two different. So cos 60. All right, then you'll have this 16.1 feet per second square. That's it, 80. Anybody found the value of a? I don't have it in my notes.
I got 27.67.
I'm writing it, hoping everybody have the same value. N square, 80 square. Does everybody have the same value? Logan there. I mean, it's just the same wrap up. The question I was explaining before. To give you some idea, two different direction, and you have this left pivot diagram, right one is kinetic diagram, and obviously this W get distributed to W cos theta, W sin theta means theta 60 here, and then if you do the equation of motion for these two different directions, you come up with the two values T and T. So if the AT, N can be always found easily, V square over rho, and rho is in this case radius aperture, which is given as well. What is the value of the radius given here? 10. Yeah, we're going to use that, and you're going to find the L value of the N, and the value, find the value of the A. Okay. By using it. Any question? Not, then you guys have a good break. Thank you. Look for the homework. So I'm gonna upload a homework. You don't have to do it now. When you come back on Wednesday, week 8, it's due. It's to. Brad, you want me to put it like which part you are doing now?
Give me a second, I got it. The weight, right, and the mass the same?
Where